Okay, so here's just a quick video to help illustrate how the hyperbolic or paraboloid, when it's warped, is created. So earlier we were showing how it looks in elevation and plan and introducing what it looks like with the edge view of the director. But how it's actually created is how I'm going to show here now. And this is just a quick little sample question. And I'll just read it out here to you. Points B and C are on the horizontal plane with A and D 70mm and 45mm above the horizontal plane respectively. Draw the elevation of the doubly ruled surface below and show the elements of the surface. Each side is divided into 5 elements. So as you can see here, we have down in plan, we have our shape here, which is A, B, D and C, as you can see, and then we have to find the elevation. We have to find that shape warped in elevation, as you can see up here. So there's the plan, and then there's the elevation. So as you can see, we're given in the question. I just have a ruler there for scale just to show you that the points. So we're able to find A and D because we're given them in the question, and then B and C sit on the horizontal plane. So that means that they're going to be on the XY line, as you can see here. So then, as you can see, B connects to D down in plan, so then B connects to D up in elevation, and then A connects to C down in plan, so then A connects to C up in elevation. So that'll give us our kind of outlying structure, kind of like this, kind of the overall kind of outside shape, as you can see here. But how do we actually find the divisions that the part is going to be made up into? As you can see here, it's divided into 5 elements. So how we do that then is to start, as you can see here, we have 4 sides. What we divide up into 5 parts. That's through the dividing the line construction, which is what we would have covered, and I'll just show you here just in case you quickly don't remember. You just draw a line out here, any distance. As you can see, we'll use B to D as an example. You divide it up into your required parts on your compass, which would be any length you want. You mark your 5. You connect your 5th point back to the edge of the end point of the line you want to divide, and then use your rulers then to equally divide it up, then using sliding the rulers as you do it to get your different points, and where they come back to your original line is where it's going to be divided up into. So you do that for each of the sides, and then what you do is you project where each of those cut straight up, and where they cross, as you can see, we'll use this as an example here. We divided up our line, as you can see here. We then brought it up, and because there is the point as it's dividing B to D, as you can see down here. So then there's B to D there, and as that goes up, that's where that divides. And then you do the same then up above once you have this divided from A to C. So then there's A to C, and where that comes up, then you get your point where that crosses your A to C line, and then you connect them together like that, and then you repeat that step over and over until you have your different divisions on the point. So that's how you quickly actually construct the hyperbolic paraboloid as a warped surface in the plan and elevation.